Hi. Oh, we're going to work with this. Okay. Today I'm going to talk about intelligence amplification, some background, why it's important, and some of the patterns and things to consider if you want to build systems using data analytics that improves people's abilities. It was originally intelligence amplifications with artificial intelligence, but there's so many names for the same thing, and I thought I'd avoid buzzwords, and we'll just go with intelligence amplification and see where we end up. So I'm going to talk about how we can think about taking data and analytics, machine learning, machine intelligence, and using those techniques to radically change the behaviour and capability of people in their daily working lives. To start with and put in some context, my experience has been using data analytics, expert systems, people analytics in the enterprise. So the lessons and patterns I'll talk through are mainly targeted to that domain. So generally an environment that is slower and dumber than I guess most of the participants here would see. So intelligence augmentation, intelligence amplifications, human-in-the-loop computing. It's about using the tools we have to help humans deliver what they do better. The tools and techniques in data analytics are about extracting intelligence and ultimately insight. We're in the intelligence game and we'll be at the forefront of shaping profound changes in future work and society. Yay for us. There are many challenges in the field, and one of the greatest challenges I think we face is about getting that intelligence into the hands of users. This talk won't be a catalogue of patterns on how to solve specific problems. Largely the prerequisites for the next generation of intelligent experiences are only just coming together, and much of that work remains to be done. I hope that by going through some of the thoughts from the experience that I've had, it will also help you get thinking on what you think the future should be. So we're in a revolution apparently, and a key differentiator of the technology revolution from previous societal changes is the speed of diffusion of new approaches and technologies as they emerge. Intelligence amplification has a long history, and with the convergence of technologies, knowledge, and economics of delivery, it means I think we're about to start a major iteration in the field again, and that warrants revisiting what we do, how we do it, and what we want to do. So, we're already seeing fundamental changes today in the work people are being asked to perform and the ways that they do it. There's much active research into the field. McKinsey think that 60% of all occupations, 30% of their constituent activities could be automated with current technologies. Current being the operative word there, which makes me think they're having a dig at the engineering team, which is typical enterprise. It's not limited to mundane, repetitive, low-end jobs. It turns out a lot of management, law, medicine, technology have many tasks that are largely repetitive and predictable. It turns out intelligent systems are becoming really, really good at that kind of work. It means that the changes we're seeing, we need to not only reconceive our ideas of what lower-end jobs are, but also what we consider professions. When you think about it, many silk-collar professions are about matching knowledge, expertise, interpretation, and then applying a set of patterns and actions, and we've built a profession around it, and in some cases legislated that that profession exists. So if the systems are having disruptive effects in the workplace, automating and replacing jobs, we'd expect outputs to be rising, super productive companies, and happy people. We're all going to need a universal basic income. Work will disappear as we know it. The 4-hour work week becomes a default, and we'll all retire to be gardeners. But it's not kind of working out like that. After initial tranche of innovation and productivity, it seems like we've changed work, many new types of jobs created, many roles that are different than what they were, but we haven't seen massive reduction in work hours. In fact, most people are doing more working hours than ever and only incremental net productivity gains. So why is this playing out this way in the enterprise, and why are we barely seeing incremental growth in our productivity from technology? While expert analysts say large amounts of the work can be automated, in many cases it isn't. I think data science, analytics, and machine learning are proxies for automating intelligence, but if you've introduced these tools into an organisation, then you should be very aware that the pace of change can be glacial. Very few organisations are truly fundamentally adopting digital transformation, and from what I've seen, it's more of a gradual eating away from the bottom from motivated individuals. I think the adage, the future is here, but it's not evenly distributed, holds very true. I fear in particular Australian enterprises aren't seeing the disruption and opportunities as fast as our overseas brethren, and it poses significant commercial risk of being subsumed by global players who can significantly leverage global data and then ultimately insight faster. Companies are information machines, and with network effects, a sustaining advantage goes to companies that can create virtuous loops, enabling better outcomes from data insight and then growing and increasing their information stocks. We've seen it very much play out in the consumer spaces as organisations aggressively protect and try to lock in their data, and I believe we will continue to increasingly see this played out from global competition disrupting local incumbents. The question becomes here, how do we introduce the advances being made in the machine intelligence space into people's lives? I think companies are looking for the 10 times factor. If they're willing to impose significant organisational change from new structures, technologies and skills, then they need to see a radical improvement for the cost. The good thing is we're ready. There's been a series of incremental disruptive changes that have been building, and we're in the stages where combined in a new form, they can help us develop and enable new solutions. So cheap computing, I'm sure everyone in this room is aware that the economics of infrastructure has changed. The biggest cost in getting new innovations off the ground in analytics isn't the sunk cost of new racks of kit. It's likely the high and well-earned salaries of the experts. Bulk and systemised API data access. It's pretty much impossible nowadays to find a modern piece of enterprise technology that doesn't have relatively solid APIs for obtaining and manipulating data to integrate into the organisation. Many have PubSub, and with integration platforms as a service, many divisions inside the modern org have an API front end to their business, even if they don't know it. Stream-based and real-time analytic platforms, Kafka, Storm, Apache Spark are all production tested, and with massive throughput they allow you to start quickly with strong documentation and information. Lastly, productization of the tools and techniques. The open source commercial hybrid is a good pillar for analytics products. Gone are the days of finding code on a university website, compiling it, getting it working, trying to understand if the problem is you, the data, and scaling that into a commercial product. So we're all familiar with intelligence amplification. We use its inventions every day. In December 1968, Douglas Engelbart and his team developed a system that gave us windowing, the mouse, video conferencing, hypertext, collaborative editing in a radical new user experience with the goal of amplifying human abilities in 1968. Intelligence amplification is a pretty simple philosophy. How do we use tools to improve what we do as humans? I think this is a great, simple philosophical framework for thinking about the systems that we build, what we deliver to users, and we tend to get too detached from them too easily. It's particularly relevant to analytical systems as we move beyond process automation for our systems and move into automating decision-making and using machine intelligence to make judgments. We're trying to achieve the end goal of making decisions faster, more accurate, with the most information. And if IA is the core of our thinking of why organisations should adopt these systems, then I think we'll have an easier time introducing complex systems that are subsuming decision-making into organisations. So, if we want to think about a future where we build these systems, there are some characteristics and jobs that machines are better at and others that where humans excel. When we introduce new systems, we tend to be in the automation habit. We tend to put on a process automation hat and examine it, do a value stream analysis, and build a new system from that. We get anchored in process flow thinking. I think that gets incremental improvements, but we can get a better return if we start thinking from the top down. If you look at the set of traits, then much is predicated on the use of information, knowledge and expertise in different manifestations. Why in society do companies exist? Well, economic theory tells us that organisations exist because they are more efficient at exchanging information, exploring, curating and leveraging shared knowledge to make faster, more accurate decisions with better outcomes. When we adopt these systems, we need to look at the core problem being solved from an information point of view. Look at what's being used, what's being decided, and what is the ideal outcome from the intelligence provided. it's easy to forget the fact that we've never had an experience where the decisions have been made by somebody that's not human. So, what's wrong with this picture? I think the intelligence amplification philosophy is going to be key to leveraging the insight we're building in our data analytics systems. Anti-patterns are a valuable tool to show the error of thinking, so we're going to start with Tom Cruise. It's a relatively well-known conception of a future UX designer's love, but it's not quite in line with the way our systems are evolving. This is a great example of extending and optimising mechanical intelligence amplification. Seamless transfer of data, responsive user experiences that provide a highly productive work experience, video conferencing, gestural interfaces, it's all there. The only problem is that the only thinking being done in this future workplace is by the people drinking coffee and hanging out in the office. There's an inductive jump by the protagonist, but he shouldn't need to go into the office and put on fancy gloves to confirm it. He can ask the computer, or better yet, if there's a suspicious villain who is in an odd place sneaking around, then he could have brought it to his attention a long time ago to review the anomalous pattern. More Tom Cruise. So the challenge to deliver the experiences that provide affordances that take the power of the data analytics we have and give it to users is the primary challenge. Up until a few years ago, the biggest challenge was being able to apply analytical techniques in the first place. We couldn't get the data, the knowledge wasn't widely disseminated. Building and scaling a team that knew data science, analytics, or machine learning meant it was largely impossible to do unless you had extremely deep pockets or significant timeframes. That's changing, and I think a lot of the future potential is unlocked by the technology reaching critical mass, but more importantly, it's economically feasible for small, innovative teams, which is how big organisations tend to get genuine innovation coming through them. We're seeing analytics and intelligence emerge as an API. Organisations with rich data pipelines are productising the building blocks and packaging in cost-effective APIs that are increasingly trivial to embed into applications. Interesting, I think right at the moment, Google, Microsoft and IBM are using this as a commercial wedge over Amazon. It will be interesting to see how Amazon packages their intelligence offering, which will be inevitably coming. I'm going to say in particular for enterprise systems, exposing analytics, most of the implementations we have today are pretty much glorified search boxes. We input some terms, we filter, we might output an elegant interactive visualization, but much of the intelligence is still being driven by human understanding and thinking, which is why I think self-service analytics is a large challenge. The insight still typically requires an expert data scientist to know what questions to ask, where to drill, and what data to connect it to. There's some great people pushing the boundaries and doing interesting things, but for the enterprise world, my experiences are that most organisations today are still in the neophyte stage of leveraging the intelligence of their data. So, most of the way we build systems today is flow from our standard n-tiered model. We have an elegant front end. It's usually got some kind of mediator that takes our inputs and coordinates to the intelligence systems on the back end. I think similar to Conway's law, our systems and interactions represent the architecture of the system it's deployed in. So what's different when we think about intelligence amplification as opposed to thinking about delivering great user experience? Well, the particular differentiators to consider are multiple inputs and outputs. Most of the systems we're using typically respond to inputs from a single interface at a time. Many times it's a web browser, and we respond to clicks, text, input, standard UI mechanism. But to deliver our intelligence amplification experiences, we need to broaden our inputs again. We need to look at other inputs that now needs to include speech, inputs from cameras, which give us gestures, and then importantly, other states of the world. Today, that means real-time API integration into external systems that we need to support fast query, or, given the context, provide a subscription to real-time information. For fast responses, that typically means introducing a fast cache, or if using an analytics, it means wholly importing and synchronizing the external data. Real-time and streaming. In the enterprise, most of our systems are sitting behind a web browser, responding to user actions, and due to the woeful state of enterprise UX, users are accustomed to systems that take tens, well, hopefully seconds, to respond. From an experience that empowers these users, all those inputs are constant streams of data and they're now coming in real time. For example, if you're using Get User Media extensions now in all our modern browsers, it means we can now capture microphone, camera, data along with the user interacting via the keyboard. Lastly, the difference between, say, an enterprise model and a generic model is we have specialised verticals. We have a fair idea of what the user is doing, what they're trying to achieve, which means that we can use that to have a crib and infer intent. So our systems need to respond differently as well. Responses may mean proactively providing prompts or related information actions and suggest initial decisions requiring approval, refinement, or human judgment. The first thing is being responsive. That means being fast. Imagine if you're providing real-time guidance for a legal conversation in an augmented experience. You need to be taking those streaming inputs, processing, and then connecting that information and responding with events in real time. Our responses need to be measured in microseconds, not seconds. This has greater implications to the communications protocols we use in the enterprise. Most tools nowadays are web tools, and it means we need to look at stream-friendly protocols such as WebSockets and HTTP2. Our responses need to be inferential and context-sensitive. If our systems are making decisions and offloading thinking, providing intelligence, then our back-end systems and responses need to have a much deeper understanding of the user and what they're trying to do. That means your back-end knows what your front-end is doing. Because in the enterprise systems, users are typically focused on achieving something that we know about. Then to be responsive, we can make educated guesses about what they're doing and proactively start processing. If we're using an off-the-shelf tool, then it's typically a generic solution, and you will still need to tune to the context of the user. That's often more difficult than you'd hope. So, if we want to start achieving intelligence amplification experience, then we start seeing a different architecture emerge. We see substantial intelligence in every layer. In the experience layer, we have to respond concurrently over multiple mediums. An example of responding may mean something like verbally responding to a query, updating something on the screen with more details, options, decisions that need to be made, and then sending a Slack message to indicate to the wider group and chatbots that something has happened. Our communications need to become event-based over stream protocols with low latency. State becomes independent at each layer, and cross-state communication means you need to worry about versions of the truth and who should be responsible for determining that truth. Who should win? What the users have told us, or what the data is telling us. We end up with an increase in analytical models and systems that we need to interact with concurrently. We have smaller, less intelligent, fast systems, optimised to give probabilistic responses faster, and then slower, more intelligent systems for understanding. It means being responsive, and as techniques and technologies change, quickly being able to weave and knit systems together. For example, in a speech analytics context, understanding the sentence we have heard and its subject versus understanding seeing if the sentence started with the term like. There's two major facets of starting down the path through your applications and systems. The first is architectural. That means experimenting with stream-based architectures and messaging platforms. It means looking to cloud-native and reactive architectures. It's a valuable journey in its own right for scalability and reliability of your systems, but it makes introducing analytical systems easier in my experience, particularly in the enterprise. You tend to create a business processes API between your layers, and it means it's easier to update and introduce intelligence into the system. Getting good at log shipping and replay from a testing from a user perspective is important. It'll give you good insight into what's important for making decisions in your systems, and if you don't capture and log it today, you can't replay it to introduce the behaviour. Good visualization tool like Splunks are also a prereq, or for this group you could build your own. Second is more important to intelligence augmentation. I'd advocate starting to think about the fundamentals of the organisation, the information and the users in it. It means re-examining existing process and automation and trying to understand what decisions and investigations may be better for machines and what characteristics you want to amplify for your humans. And that would help people make better, faster, higher quality decisions and then thinking through approaches to give them the information and facilities they need at the right time. So I think that was a whirlwind tour of intelligence amplification and some of the challenges and constraints of starting to expose some of the intelligence of the systems we're working on, with a tipping off point to jump in and start thinking about and the experiences we need to start building.